With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today we are going to discuss one question of continuity and differentiability. Here we are given a question in which we need to find the total number of points where this given function f of x is continuous but it is not differentiable. So let us see what function we are given. We are given f of x as the maximum of the three functions, that is the signum of x minus under root of 9 minus x square and x cube. And we are given four options and we need to choose one among these four options. So first of all, let us draw the graph of this function f of x. So first of all, let us consider this function that is minus under root of 9 minus x square. So for its visualization, if we consider a circle which is centered at origin and has a radius of 3 units, then its equation will be given by like this. The equation will be x square plus y square is equals to 9, that is 3 square. Now from here if we find the value of y, then from here we get the value of y as plus minus under root of 9 minus x square. So here plus sign represents the semicircle which is above x-axis, that is positive, and the minus sign represents the semicircle which is always negative, that is below x-axis. So this function, that is y is equals to minus under root of 9 minus x square. It is basically a semicircle which is below x-axis and has a radius of 3 units. Now let us also memorize what is signum of x. So signum of x is defined like this. Its value is basically equals to minus 1 when x is less than 0, and it is equals to 0 when x is equals to 0, and this signum of x is plus 1 when x is greater than 0. So the signum function is defined like this. Now at last we have this x cube function, and all of us know that how they say y is equals to x cube looks like. So now let us try to draw the graphs of these functions. So here we draw the x-axis and here we draw the y-axis. Now let us name the axis. This is the origin O, this is the x-axis, and this is the y-axis. Now let us draw the graphs of all the three functions, that is signum x minus under root of 9 minus x square and x cube. So let us first draw the graph of minus under root of 9 minus x square, which is a semicircle below x-axis and has a radius of 3 units. Now here we have drawn this circle whose radius is 3 units and it is centered at the origin, that is 0, 0. So this length is 3, this is minus 3 on the axis, and this is also minus 3. And let us say this is 1 unit and this is 2 units. And here we have minus 1 and here we have minus 2. Now let us draw the graph of the signum of x. So since we know that signum of x is positive for all x greater than 0 and negative for our x less than 0. So for all x less than 0 it would be minus 1. So the graph of signum of x looks something like this, and for all the values of x greater than 0 the graph of signum of x looks something like this, and at x is equal to 0 the signum of x lies here, that is at origin, and here we have the open interval and here we also have the open interval. Now finally let us draw the graph of the y is equals to x cube. So its graph looks something like this. This is the graph of y is equals to x cube, and here we have like this. So this is the graph of y is equals to x cube. Now since in the function it is given that we need to get the maximum values of all these three functions, and that maximum value will be the graph of f of x. So let us take the maximum values of all of these three functions. So in this range we have maximum value like this. This is the maximum value, and here we have the maximum value like this. So the graph looks like this, and here we have a maximum value like this, and here we have the maximum value like this, and here we have the maximum value like this. So all these black curves represent the maximum of all the three functions at a particular point, and this is the graph of f of x. Now let us determine all those points where the function f of x is continuous but it is not differentiable. So if we look at this point A, we have a sharp edge. So we know that at this sharp edge the tangents will not be defined, and hence this function f of x will not be differentiable. Now similarly, if we consider the point B, this is the point B, then at this point B we can also say that here we have a sharp edge, and here the function is continuous but it would not be differentiable because the function is not differentiable at the sharp edges. Why? Because the tangents will not be defined. We need a unique tangent for a function to get differentiable at that point. So the function is continuous but not differentiable at the point A, at the point B, and also at this point C. At this point C, we can see that the function has a sharp edge, and hence the function will be continuous here but not differentiable. Also, let us say that this is the point P, then here the function can be said as continuous but it would be not differentiable. Why? Because this is a sharp point, and here the unique tangent or unique slope will not be defined. Or if we calculate the tangent at this point P, then it would come to be minus infinity. So if we calculate the f dash x at the point P, then we get minus infinity as the slope. So the points at which the function is continuous and the function is not differentiable, they are the points A, B, C and this point P. So there are in total 4 points, and hence the correct option would be option 1. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.